Welcome to F1 by 10 Autonomous Racing. My name is Madhur Bahel and I'm one of the instructors for this course. I'm a research fellow in electrical and systems engineering at the University of Pennsylvania. We have an exciting and a fast-paced course lined up for you, during which you will learn to assemble, program, and then race a 1/10 scale autonomous racing car similar to the one I have here. But before we get into details of this course and how these cars work, let us first take a look at a short video of these cars racing through the corridors of Penn Engineering.
Mark, you press the throttle pedal harder on the straight. Looks like your foot is bouncing off.
Transfer oil. Watch your board next time you come round.
Apparently, the last time you were pressing the button too early, so you didn't get the DRS for all the straight. Trying to activate it in the right way. Fantastic.
Make the ground shake.
You are a Grand Prix winner. Well done, you deserve it. Brilliant drive. Well done.
Wow, that was quite remarkable. And although it might be 1/10 the scale, but it's going to be 10 times the fun. In this course, you will learn about the principles of perception, planning, and control for autonomous navigation. Perception algorithms will allow our race car to sense its environment and figure out its own position with respect to its surroundings. Planning involves figuring out where to go next. In our case, we want to figure out the fastest racing line around the track while avoiding collisions. And finally, control will allow us to execute the speed and the steering commands to follow that racing line. The way an autonomous car works is by repeating this cycle of going from sensing its environment to planning a path and then to control. The planning can sometimes also include higher level objectives, such as racing strategies or building and using a map of the track. The principles that we will cover in this course are very similar to the ones used in designing self-driving cars today, although there's one key difference, and that is speed. In Formula One racing, there's a saying that if everything seems under control, then you're not going fast enough. And the same is true for our scaled version of the race car. Speed poses a difficult challenge from going from sensing or perception to planning and control. The challenge is in closing this loop fast enough to avoid crashing the car. It's no different than a racing driver crashing into a barrier as a result of his slow reaction time. Pushing the boundaries of perception, planning, and control for autonomous cars is already gaining a lot of attention. Here you can see a concept autonomous race car which uses GPS signals to find its way around the track. The car also uses 3D cameras to scan the track in real time and then orient itself correctly on the track. Last year, a global all-electric racing series called RoboRace was also announced. The idea behind this competition is that it will attract the fastest autonomous cars on the planet. And the focus will be on developing better algorithms and artificial intelligence to win the race. To understand how this course is organized, we first require a brief introduction to the fast-paced world of Formula One racing. Many people, including myself, undeniably consider Formula One as the pinnacle of motorsport racing. These cars are capable of doing some incredible things, and the technology developed in F1 is second to none. A typical Formula One season will have about 20 races in a year. For each race, the race weekend is spread over 4 days and consists of practice sessions leading up to a qualifying session to determine the starting position of the cars on the grid, and then finally the race itself. This course is organized as a long Formula One race day weekend. We will begin with practice sessions 1 and 2 and then move up to qualifying, and finally the course will culminate in a race. Practice session 1 is about preparing the car and getting it ready to race. In practice session 2, we will include programming the car to run in a straight line. During the qualifying session, we will program the car to drive in a loop. And finally, for race day, we will add the ability for avoiding collisions with other cars so that we can run time trials and even race other cars. The website for this course is f110.org. This is where all the course material will be posted. This will include video lectures, tutorial videos, and lab exercises for each of the sessions. Links to code repositories that you will need during the course will also be posted there. On the website, you can also find a complete list of parts that you can order to assemble this car yourself. There is also a forum on the website that I encourage you to join so that you can post questions that other students or the TAs can answer. Racing drivers have often jokingly acknowledged that they know that they are the slowest part on the race car. In this course, we'll get rid of the driver altogether and have driverless teams compete in a battle of algorithms. So put on your racing gear, and next time when we meet, we'll get started on how these cars work.